Previous video, we created our hello world donut example. It's called torus technically, and we learned that how we can have it animated. But if you look at the SCN, the torus geometry, it conforms to it's a basically a subclass of SCN geometry. So if we Google for that SCN geometry, and in the Apple documentation we get a lot of by default objects which is being provided conforms to the SCN geometry. So if you see, there's an SCN box which has height, length, width, and chamfer radius. Chamfer is nothing but how smooth the edges of a cube is. So let us try to bring in this one for the sake of clarity. Okay, so in this node, instead of torus, let us rename this into node. Okay, so let us add a new node, node geometry. So the geometry type is SCN box. So when we have that, we have those similar options what we saw here: height, length, width, and chamfer. Those options are available. So let us have the value as 1 1 1, and I don't want any chamfer radius. So yeah, if we now try to run that, you can see what all the values what we have set previously are still applicable, and our cube box came into life. So let us change the chamfer radius to see whether what it says is the correct one. Yeah, if you see the radius here where the two faces are intersecting, it's not sharp. This one, it has some curve associated with it, so that is what is chamfer radius. So that is what it is. Okay, so one more final example. So there is something called pyramid. So that is something interesting. See in SCN pyramid, and it takes width, height, and length. So again, we can go back to the documentation and then go to SceneGeometry and SCN pyramid. Yeah, it talks about length, width, and height, and you can go into the details of how many width count, all those things. But for now, let us stick with the simple things. Yeah, and then I just give 1 1 1, and then I try to animate it, and yeah, you can see that a pyramid is there, but looks like the pyramid is a little too close to the camera. And we can also do something like, we can position the node. So say for example, there is an option called position. So if you see the type of that, it is nothing but SCN vector. So we need to provide some SCN vector for that. SCN vector, and then SCN vector of CG float we can provide. For now, I want it to be on the same x-axis, y-axis, but I want to feel the depth and make it like far behind. So when I run it, it looks as if nothing has changed. Okay, so that is because the action what it is doing here, it is trying to follow the camera, and then no changes are being visible. So for that we need to have a different set of actions, so animations. For that we have something called SCN transactions. So SCN transaction, we will get into that later. SCN transaction dot commit. So and then we can provide the SCN transaction dot animation duration is equal to 5. Now if I try to change the same position what I had here, so let me correct that and paste it. Now if I try to run that, yeah, you can see that it is going 10 units behind the screen. Like, it's like the z-axis, this is basically the y-axis, and this is the x-axis, and the one which is going into the screen, that is the z-axis. The negative, that is negative z. So that is why -10, when I have given, it has gone so far in the dimension. So for example, if I make it -5, it will be little closer, and if I make it as +5, then it will come directly in front of us. Okay, so no, this is not what is happening. Okay, so yeah, we need to give some perspective. So we'll talk about that in our next session. Just before winding up, so the z-axis is the one which we are manipulating, and we can also manipulate the y-axis. But with this, for the y-axis to change, to see the changes of those things, get the actual perspective, we need to have a plane. So let us try to do that. If you see that it is floating, the object is basically floating in the air, and we don't know where the plane is. So for that we need to have something called as plane. So as usual, again the same thing. So we are going to have something called floor, that is nothing but SCN node. So again, so all these everything in the scene is needs to be associated with the node, that is nothing but one pixel or a point in the plane, and then we need to give some geometry for that. So for the floor what we will do is for the geometry there is something called SCN floor. So that is what we are going to provide, and then it does not take any argument, so or we are not interested in knowing the argument. So floor dot yeah, so basically this is how we need to have a floor, and then again this floor we need to associate it with the scene. So for that what we should do is like scene scene dot root node dot add child node, and then we need to add floor. So once we do that, so what will happen is it is showing us a plane. So if you see that the plane has some reflexive index, and it is 1 currently being set to, so that's why the pyramid's reflection is being seen on the floor, and it looks like a rhombus. Say for example, now if we try to change the position as part of the animation of the this one associated with this, you can see that this is the horizon plane, and then our object is floating in the air by 1 unit, and it is in the 5 units in the depth of the camera. So yeah, so that is how you create. So and for my findings, the you can also adjust the how deep your uh, plane floor should be visible. So you can also change the dimensions of the floor. Say for example, floor dot position, again the position is nothing but SCN3 vector. So you need to provide the SCN3 vector, and then CG float of that is nothing but, I don't want any changes in there, and I want the change in the floor dimension, and also the I don't want to change in anything in the Z. So uh, so yeah, these changes does not reflect much as such, but if you give some bigger values, you can see the value will be lower. So if I give -10, the floor value came down drastically. Okay, so it looks like the object is much higher than the plane ground what we are having here. So yeah, that is how you can control the position of the objects, and how you can also control the position of your floor. And we also learned how to animate it in a different way. Those are called transactions. So we will talk more about the transactions in our later videos.